So what are we going to be doing today? We're going to be able to identify angle pairs on lines that are cut by a transversal, and we'll talk about what all those words mean in a second. How are we going to do this? We will use the definitions of interior, exterior, alternate, and same side to help identify. And why are we going to do this? Because next week we're going to learn how to use these parallel lines and learn some new facts with this. So we're actually going to use this in a little bit with parallel lines next week. So let's talk this over. So a couple things. These are review. We've talked about these concepts before. Parallel lines are lines that do not intersect and they lie on the same plane. This is the symbol that means parallel, the two little vertical lines that are parallel to each other. Skew lines, which we've talked about, are lines that not only never intersect, but they're also not on the same plane. So, whereas if you see like on the top line, these two red lines here, these are parallel, right? This one and this one, those are parallel, right? They don't touch. They're going the same way. But like, for example, if we look at line AD and line CG, you see how not only do they not touch, but they're going completely different directions from each other. One of these is going sort of into the page, and one of these is going up and down. So, I've showed this before, but let's say you've got two lines and they're both going the same way and they're never touching. This is parallel, right? But now if I start to have the lines skew off from each other where they're not touching, but they're also not going the same way. They're like ships passing in the wind. They're not in any way, shape, or form ever going to touch like this. Not like this, but like this. These are skew. These are parallel. So we've got parallel lines. We've got skew lines. And then we have something that we didn't talk about before. These are called parallel planes. Parallel planes are like this top plane and this bottom plane here. They are never going to touch. Now, we can't have skew planes because you don't have enough room to make the two planes like off kilter from each other and never touch. Because remember, planes go out to infinity, so you can't have one up here and one sideways like this because then it goes up and it hits, right? So we can't have skew plane, not in the number of dimensions we can actually physically comprehend. You might be able to do it in like the fourth dimension, but ain't nobody got time for that here. All right, let's move forward. So now we're going to actually run some problems, ask some questions. So here's our picture. And first we want to know what segments are parallel to side AB. To maybe edge AB. Let's say edge. We don't want to say side. Can't have a side on a three-dimensional object. That's weird. So AB. What other line segments are parallel to segment AB? So we look around, which other ones are going in the same way, right? EF, that's one's going the same way. CD, that one's going the same way. And even GH, that one's going the same way. Now, some of you may be saying, but Mr. Webster, GH, that's not on the same plane. You're right. Well, kind of. It's not on the same picture, but like you could always draw a diagonal rectangle create a plane of your own. You see how you've got this plane right here? So GH is still parallel to AB. So now, the next thing we want to ask, okay, so which segments are skew to segment CD? Well, so let me draw segment CD. Remember, we don't want them to touch or go the same way. We cannot have them be parallel. And we don't want them to touch. So let's look. All these ones over here touch. But like, look at EH, right? Look at FG, right? See how they're never ever going to touch CD? And then another ones, you've got AE, right? This vertical one is never going to touch that horizontal one. And BF. So we've got 1, 2, 3, 4 different segments here on this box. On this box that are never going to touch. So yeah. So let's look at the next one. It's asking, what are two pairs of parallel planes? Well, you've got your choice. You've got actually a lot of pairs here. But we're just going to pick two. Look at the top. We would want to know what plane is parallel to that top plane, right? And so we look. What plane is parallel? What plane is going the same way, never going to touch? It's this bottom one, EFGH, right? So this one down here is parallel to the one on top. So if we want to know which planes are parallel, we look at the top one, we look at the bottom one, or alternatively, we could pick another pair, as long as we're picking the ones that are opposite each other. Like we could pick the left one over here, A, B, F, E, and the right one, C, D, H, G, right? These are both parallel, right? See how they're going the same way? And then finally, now it's asking about segments that are parallel to a plane. Well, let's first highlight the plane so we can see what we're talking about. They want B, C, G, F. And all you have to do when you're doing this, look for the letters so you can figure out what side we're talking about, right? We're talking about this back face on this box. And I want to know two segments on this box that are parallel to this back plane. And you can pick, there's a bunch of them. They only ask you to pick two. But it boils down to any segment that's on this parallel plane up front. So you could pick any of them. You could pick AE. You could pick DH. You could pick EH. You could pick AD. All four of these segments up here on the front face, they're parallel to the back face, right? And that's all we're talking about. So now these four questions are very similar to the ones I just asked you, right? Same exact picture. Just these questions are slightly different questions. So let's go over this. First one, it says, which segments are parallel to AD? Well, that was the same question we asked earlier, just now with a different segment, right? So AD Which segments are parallel? Well, which ones are going the same way? BC is, EH is, and FG is, right? They're all going the same way. Explain why FE and CD are not skew. Well, let's look. FE and CD. Everybody sees how they're going the same way, right? Remember, skew lines don't go the same way. They go crosswise and never touch. So like that's one way to think about it. Another way to think about it is look, if I were to try and draw a plane between these two lines, I totally could, right? If I connect E to D and I connect F to C, I get a rectangle, right? I know it's an ugly rectangle. I tried my best, but you know, we can only do what we can. But you get a rectangle, and you know that's the shape of a plane. So we can't have these be skew because they're on the same plane as each other. What's another pair of parallel planes? Well, which ones did we do beforehand? I think we did the left one, the right one, and the top one, the bottom one. Well, that leaves one more pair, right? The front one and the back one. This plane and this plane, right? Back here. The front side and the back side. So plane AEHD and BFGC are parallel to each other. And then likewise, here's another question, same as before, DCGH, right? They say here's the plane we're talking about, DCGH. What are two segments that are parallel? Well, they just can't touch, right? So like you could pick AE and BF. You could pick AB and EF. Both of those, all four of those are parallel to this opposite plane over here, right? All right, next we got this new word, transversal. A transversal is a line that cuts through two lines. So like, for example, see here's my line L and my line M. The transversal is the line that cuts straight through and makes these two little crosses in there. All right, so the transversal, that's this one. That's the one cutting through the two. Y'all get what I'm saying? And then more importantly, when you have this sort of situation, you get angles that are on the interior of the figure, and then you get these angles out here that are on the exterior of the figure. And you know, also with the transversal, you get angles that are on the same side as each other, and then you get angles that are on opposite sides of each other. So the angles that are on the inside of the sandwich, you know, picture like a sandwich. You know, it'll help. It'll make you hungry, but it'll help. The angles that are the meat and the cheese and the tomato and the lettuce on the inside of the sandwich, 4, 3, 5, and 6, the way that they've numbered it here, those are called interior angles, right? They're angles on the interior. The exterior angles, 1, 2, and 8 and 7, the way they numbered it here, are called exterior angles. They're on the outside of the sandwich. So exterior angles are the ones that are out here. Interior angles are the ones that are on the inside. So now we can be a little bit more specific than just interior and exterior. We can actually break it down into more than this, but these are the ones that they actually are going to be focused on. Alternate interior angles, the ones that are on the interior but on the opposite sides from each other. So they give an example here. Angle 4 and angle 6, angle 5 and angle 3, right? They're on opposite sides from each other, and they're both on the inside of the sandwich. A really good way to check to see if what you're working with is the alternate interior angles is if you trace along the lines that make them up, you get like a Z shape. Y'all see kind of the Z shape? Or if it's not a Z shape, it'll be like a backwards Z shape. It'll be a little zigzag. Angle 3 and 5 right here. Angle 4 and angle 6 like this, right? Same side interior angles are still on the inside together, but now they're on the same side. Like angle 4 and angle 5. And again, if you look and they make like a little sideways U, or the other way, 3 and 6. You see these two angles when you sort of glue them together, look at the shape that they make. So here's angle 3 and angle 6. Here's angle 4 and angle 5, right? Corresponding angles, I feel like corresponding angles tend to be the hardest ones to see and identify, so I want to take the most time with them. If you look, the way that they're labeled, corresponding angles are the angles that are in the same spot on the two different crosses. So top left, top left, top right, top right, bottom left, bottom left, bottom right, bottom right. Alternate exterior angles are angles that are on the exterior, just on opposite sides. So these, like what they give you here, angle 1 and angle 7, like that, yeah? Or angle 8 and angle 2. Y'all get what I'm saying? So that's what we got here. Now I've got some questions for you to see if you can think them through, help to remember what this stuff is. So I'm going to move on. So what do I want to do here? I've got 5 different things I want you to try and identify if you can. All right. So, alternate interior. Remember, we're looking for that Z shape. Now you notice that this is sort of laying on its side. Doesn't matter. Look for the angles that are in the middle that are on opposite sides of each other. So, for example here, angle 2 and angle 6. That's one pair. Or you could have chosen angle 3 and angle 7. That's another pair. Same side interior. Now we're talking about the ones on the inside but on the same side, right? So this guy right here, for example, right? Angle 2 and angle 3. Those are same side interior to each other. Angle 6 and angle 7. Those are same side interior to each other. Corresponding angles. Remember, we've got 4 pairs of corresponding angles because there's 4 pairs of angles. Top left, angle 1 and angle 3. Top right, angle 2 and angle 4. Bottom left, angle 8 and angle 6. Bottom right and bottom right, angle 7 and angle 5. Hey, great. Alternate exterior, once again, they're on the exterior and on opposite sides, like 1 and 5. Or uh, angle 8 and angle 4, right? Now, this last one wasn't on the previous slide, but I want to talk about it anyway. Same side exterior. These we're talking about, they're on the same side and they're on the exterior. So like angle 1 and angle 4. Or 8 and 5.